Hello. All righty. Where's the clicker?
Right up here.
Did somebody steal it?
Oh wait.
Thanks.
Nope. This one? This is it.
Nice.
I think that's
Thanks. Make sure that's not the first slide. Can we go to slide 1? That's like slide 50. So while slide 1 comes up, I'm Theo. I've been doing web operations for however long it's been called web operations. So I thought my keynote was 15 minutes and it's 30 minutes. So I'm going to creatively add to some of the slides. John said he was going to give me a really long introduction. That was funny. So I started out in academia. I pursued a PhD at Hopkins and got kicked out because I was a little too focused on commercial stuff. And while I was there, I paid the bills by administering the office systems. So all the network that powered the computer science department. And it was really interesting. We had this joke all along where we would get paged at 11:30 at night that the internet's broken. And it was always the same page. It's the internet's broken. And we were only on the internet 2 at the time, really. So which dates myself a little bit. But it was always from a different professor. And it was like, oh, if that professor said the internet was broken, it meant that the printer was broken on floor 2, right? And it's really interesting. We laugh about that. I don't know how many people here have worked in IT before they really went into the web. I mean, are there a good number of people? Yeah, so you kind of understand this culture of users in general not really understanding the deep technical mechanics of computing. So you'll always get error reports that are like, hey, the web page is broken. It's like, really that's not useful because the only complaint I ever get is the web page is broken. Maybe the JavaScript is broken, or maybe this line in this JavaScript file is broken. Since your browser tells you that, that would be helpful. But we don't get that, right? So this archaic problem reporting and troubleshooting thing that's prevalent in IT is actually really prevalent in web operations too. So as much as I wanted to escape that, I could not, unfortunately. So I came here to talk to you about having a career in web operations and what that is and why you might want that. And I think I'll stop in the middle and talk a little bit about how I see changes in big and small sites, because we're really growing up. It's one of the themes that Mr. Allspaw always says is, we're teenagers and we're starting to grow up and kind of need to get some responsibility and, we need to learn how this stuff works. I work at OmniTI. We're a consulting company. We service about 10% of the Alexa Top 100. So what we focus on is building highly scalable systems with hundreds of millions of consumers against those sites. We build back-end systems and front-end systems, infrastructure design, data center deployments, disaster recovery, all sorts of stuff. So we really do see a full gamut of the problems that one faces when they're just building a website. So that stuff ends up being a little bit more complicated. So what's a career, right? A career is a pursuit, right? It's a willingness to mature, and you have to have patience to become exceptional. Otherwise, I would just say you have a job. You wake up in the morning, you go to work, you do what you're supposed to, you go home. There's no self-betterment in that, right? You want to become a master in these things. That's what a career is really about. And what I see all of the time are job ads, right? Again, I see them a lot because I write them a lot because I can't seem to hire fast enough. I assume everyone else has that problem as well. Can't hire people? Yes. The reason is because everybody learned that, 21% of the GDP growth is in computing? That explains a lot why everybody wants to go do this. This is not remedial labor, right? There's a lot of intelligence required in delivering this stuff, but what we get from applicants doesn't articulate that very well. So Java expert, right? We get so many people applying for jobs as a senior and expert level that came from nowhere. They just graduated from school. They've done like 12 academic projects. They've never written code that had to run at 3 a.m. in the morning for millions of users. That's not what they do. They have no expertise. They have skill. They have some knowledge. They have a little bit of knowledge. And hopefully they're very, very smart, but they're not expert. And I will call this as bullshit. And this is a huge problem. I think this is one of the biggest problems that we have, and I think there are all these micro problems around. I live and work right near Washington, D.C. in the U.S., and the Department of Defense is there, and all of the government contractors are there. And apparently, you can get paid a disgusting amount of money for just being able to keep secrets, not being able to competently execute on computer systems. So we get applicants that come in who are senior level expertise. The only thing they've ever done is basically answer a pager and call someone to fix a problem. They don't actually know how to use a computer, and yet they're paid 140,000 USD a year. And how do you hire that? Like, how do we as internet professionals build a team of exceptional people when we have this imbalance in the market of people who are overpaid that underdeliver? And I don't think it's unique to our business, but I certainly feel it every day. And I think that's specific to Washington D.C. area. But if you look in places like Silicon Valley or other startup-centric regions, people are so desperate to hire, they end up hiring people who aren't quite as good and pay them just as much, and they skew everything. So that's a huge challenge that we face. And your career is about being better. It's not about making more, right? So you need to not gauge the success of your career, as so many do, as your salary step increases, all right? If you want that, you should work in a civil position. You work for the government where you get a step increase or what have you. In this, it's about opportunity, and that doesn't always reflect in money. But I think to be truly excellent, you have to treat this as you would treat any other art, right? If you are a martial artist, this would look extremely familiar, right? This is basically the mantra of any good martial artist, is that you have to treat what you do as a craft and become a craftsman at that. Right? You have to become what you do. Separation of work and life, I'll let you deal with that one. But you really need to embrace what you're doing and become better. So the first step is to educate yourself. This, I think, is really easy. There's just so much information out there. There's so many tutorials, there's so many conferences, there are so many forums in which you can educate yourself. The second is to be disciplined, and I think this is where I can't help you, or you have to help yourself be disciplined. Right? Hopefully you have a structure in your work environment where you have to deliver things, you have to deliver them on time, you have to make hard decisions. Those hard decisions lead to being disciplined. And I suggest taking up a hobby that requires discipline as well. For example, martial arts or art. All of those things require a tremendous amount of discipline to be good. And that's one of the things I see lacking. We hire people who we have a good track record of not hiring people who have bad discipline, but we get a lot of applicants that really clearly have no discipline at all. They just want to go out there and use shiny new technologies to implement cool things. Really, if you have a business that does that, more power to you. But we have a business that helps other businesses empower themselves, right? Somebody decides, I want to sell knit hats online. Right? Or I want to build a marketplace, or I want to sell lottery tickets, right? There's a business there that has clear business goals, and the technology there is not to showboat, right? It's there to enable that business success and be better than competitors. And it's not about shiny new, right? And it's not about how cool can I do it or how complex can I make the solution, right? It's really about how do I get this business goal achieved? And if you approach it that way, there's still a lot of shiny stuff there, right? There's a lot of really interesting technology and a lot of innovation that happens. But if you approach it from the wrong angle, you end up with a big pile of shiny crap at the end. So the other thing is to learn and share from your peers. So this is the third step, and this is why everyone's here. And I think in all of these conferences, as much as we try to organize the talks and all of the topics, the conference is made by the people, and it's made in the hallway a lot of times. So I suggest that everyone here make this the conference that it can be by talking with each other in the hallway about the stuff that's here, about the stuff that's on your mind, about the stuff that's at work that you're allowed to share. Because you don't know these people, hopefully. There's a lot of people that you don't know, and they have unique opinions, and they have different ideas than you do, and this is where you come to share. Oh, there's 4 steps. Crap. Be patient, right? So this is what I alluded to with the whole. I'm an expert in Java because I did 12 academic projects in it and graduated last year. All right, that demonstrates one, naivete, but it also demonstrates a lack of patience. And we see this a lot where someone's like, well, why would I go work for a consultancy? Why would I go work for a Google? Why would I go work anywhere when I can be CTO tomorrow by starting my own company? Right? You just need some perspective on what CTO of your own company tomorrow means versus an 8-year practice senior engineer at Yahoo or Google. And Yahoo gets a lot of laughs sometimes, but the senior engineers there are exceptionally well-positioned senior engineers. They're really capable people. So, and the reason is because they've been solving hard problems with groups of people for a long period of time. They're exceptional software engineers. And if you think you're an exceptional software engineer after 3 months of working on open source, I suggest gaining some perspective over time, right? So a career is in this stuff. So what is this stuff? This stuff is web operations, right? But you say, I do web development. Let's see if we can do a quick show of hands. How many people here do web development? Okay, that's about 30%. How many people do UI development? I'm talking JavaScript, CSS, HTML, that sort of thing. Okay, how many people do usability assessment, usability programming, things like that? Only a few. How many people here would say they do systems engineering, where it's infrastructure design, that sort of thing? Okay, well that's good. Those are all completely different disciplines. They are completely different disciplines, and in order to have a career in web operations, in my perspective, you can't have a career in those, which is a really interesting shift. You don't do all of those things. You do web operations. The web changed all of this stuff, and the cloud made us realize that. And the reason for this is that your website is SaaS. Assuming that you do not run a static brochure website, your website is a service you're providing to your users. And guess what? Somebody wrote the software for it, so it's software as a service. It may not look exactly like Salesforce, which really legitimized the term, but it is software as a service, and your product, your users, your systems, your features is, yes, one copy, right? There's one copy of the software that runs for all of your users. And it has to evolve, and it has to compete, and it has to perform, right? All of these things together mean that it has to operate. You have this one platform that's providing everything to your users. Sure, you have a dev environment or 50 of them, and you've got a couple staging environments, but typically speaking, you have one production environment, and it powers every user you have. And if it's highly scalable, you probably have those things in different shards or different partitions, or you have them split out into different swim lanes. But it's still one architecture with one software development paradigm behind it that's pushing these deployments. And what does that take? It takes DevOps, right? And now I will start the controversy. And I say a lot of things that are controversial, which is probably why people find it amusing to hear me talk. I think DevOps, in a lot of ways, is bullshit. And I play devil's advocate a lot. So if DevOps didn't exist, I would be arguing for it. But we have a pendulum, and it has swung uncomfortably in the other direction. DevOps is really about putting development strategies, everything that software engineering has learned over the last 20 years, and giving that to these poor operators who apparently can't do anything for themselves, right? And I'm exaggerating a bit, but it's giving software engineering and deployment and all of these agile processes, Kanban, Scrum, all of these things, and figuring out how they can make operations better. So the reason, and I say it's not fair. It's not fair. I'm not a fair person. DevOps is really incomplete. It's interpreted wrong. It's too isolated. It really isn't about putting engineering into operations. In my opinion, it's backwards. Software engineers have so much to learn from people who operate systems. And I say that because I started operating systems before software engineering. We need everything to be ops-oriented. People focus on the dev part of DevOps. I think they like to focus on the ops part because they didn't do that before a lot of times, but really it's about development paradigms in operations. What I want is operations paradigms in everything. I want them in software engineering. I want them in finance. I want them in marketing, for God's sake. Marketing is so frustrating to deal with sometimes because they don't have the same operational acumen as like mission critical operations teams. So, because star is a glob and we don't like globs, and then regexes make you feel more comfortable as engineers. But every department needs its own, basically its own operations mentality inside, and they need to mirror each other throughout the organization. So, and everyone in your organization needs an operational mentality. So your job is to build these systems that operate. I don't care what your job actually is. Your job is to build systems that operate. And you need to remind yourself of this. So your job probably looks something like this. How many people's job look like this? Something like this. So half the crowd, good. So this is good. Ops' job looks like this. How many people in the crowd's job looks like this? Right, okay, well that's almost the other hand, some overlap, which is really good. So this is really interesting. And honest truth, 10 years ago, my job looked like this, and then I hired people to do that, and then my job looked like this. And now everyone who I work with, their job is basically both, which is really important. And the reason is because operations pixie dust doesn't exist. Right? People think that the cloud is operations pixie dust. I don't have to have like an SA team anymore because I've got the cloud, just spin it up. Amazon is my SA team. And that's awesome because we get a lot of business that way. All right, so it's great for us. I think it's a pretty broken mentality. So provisioning virtual systems, the cloud didn't change that. Right? Virtualization changed that. Virtualization existed long before the cloud did, really. And then the cloud existed long before the cloud was called the cloud. But when virtualization happened, it allows us to deploy from scratch environments very quickly and have repeatable scenarios. So development can all be done on identical systems by just deploying them. This was really easy. So this is interesting. This is more interesting to me because this is the part that nobody seems to understand. I'm sure a lot of people actually understand it, but they don't talk enough about it. Managing risk and liabilities is simple, fast, and painless if you skip it. So there are so many people that say, I deploy in the cloud, it's no problem. I'm like, well, how do you do security? How do you do that? And they're like, oh, my system's secure. Like that is not how one does security, right? There is a process for doing security. Where is your process? Where is it documented? We're like, well, I just apply all the security updates. Like there's just this huge gap in what is really required to deliver a secure infrastructure. And there's not enough diligence paid to this. Just like in security, right? Analogy time. Security is not a feature. How many people have ever seen this basic set of slides? Security is not a feature, right? It is not a deliverable in a project plan. You don't put it at like QA at the end, right? It's not phase 2. Let's build it and then build it secure. You cannot deliver security that way. It's a state of mind. It's a state of being. It's a mentality through every step of the process, or you're left with a hole. And it doesn't matter how small it is, you're fucked, right? So security is a very, very difficult thing, and I say operations is exactly the same thing. If you do not have an operational mentality at every step through the development of your product, you are left with an inoperable product at the end, and it will screw you. So, back to your job. Your job is not this. Your job is this, right? And this, I think the cloud changed in a lot of ways because things move faster now. And I listened to a very interesting talk by Ben Fried of Google. And he was talking about his experiences at a trading platform, trading company on Wall Street long ago. And he was talking about software engineering and operations and all of these things. And it was a really interesting parallel. So when we look at like the Industrial Revolution, right, we figured out how to do things quickly. And those things were always the same. Let's produce a car. Let's produce 10,000 of them. Let's produce shoes. Let's produce millions of shoes. How do you do that, right? Well, it's the same shoe every time. So what we're going to do is figure out how to optimize each piece of these things, and we're going to silo those people off, and there's going to be one person who knows how to sole a shoe. We're going to have another person who knows how to form the leather, another person who knows how to put it through the sewer. That's great if you want to produce the exact same shoe every time. So the Industrial Revolution gave us some pretty powerful things for commodities. And this is where I think we're at this huge turning point. Right? The web today is not a commodity. These fast websites, the user expectation that their website comes back in less than 200 milliseconds, that is not easy to deliver. You cannot cookie cutter that. I think in the future you will be able to cookie cutter that, or we've really screwed something up. We are not there yet. Because we are not there yet, we screw ourselves by being siloed. If you are a network guy, or you are a systems guy, or you're a Ruby guy, or you're a JavaScript guy, you're looking at this one sliver of the system where you need to deliver something that's rather innovative, right? You need to deliver a site in under 200 milliseconds. And guess what? It's not just JavaScript. It's the whole stack. It's networking, right? You have your data center connected over IP. You're talking BGP. It goes through layer 2 switches. It goes through firewalls. It goes through load balancers. It hits your front-end website. It gets CSS and JavaScript and HTML. It's going back to probably 3 or 4 backends like Redis and React and Postgres and whatever, right? And there's storage systems behind that. All of these things, most importantly to the goal of keeping users happy, every one of them introduces latency. And if that's not your problem, you can't solve it. So what we are in is we are on the edge of something, because delivering this is hard right now. It's not standard. It's not that everybody delivers their site in under 200 milliseconds. So you are pushing the envelope. You are trying to be better than everyone else. And to do that, you have to innovate. And when you innovate, you have to be a generalist. You have to do it all, which is why this is your job and not Java. Right? Java is the job of a Java programmer. C programmer, databases is even too general, right? You have a MySQL administrator or a Postgres administrator. Packaging experts, right? I mean, there are people that just do packaging. They have a place. It's a very important place. If you're releasing software and you need to push it to 10,000 clients, you damn well better have a release engineer and a packaging expert on staff, because you're producing 10,000 of them and they have to work every time. Right? In SaaS, you're producing one, and it can't ever not work. It's a very different paradigm, and you need to be able to do all of this. You can't have any boundaries. So you are a generalist. And this is your path to having an exceptional career in web operations, is by embracing all of those things. So the first rule of all of this is what you build will break. Coming back to, has anybody ever built anything that, I won't ask, has anyone ever built anything that hasn't broken? Because there's probably a whole bunch of people in the crowd. Come on, I've built stuff that hasn't broken. Artur, you can't be the only other one, right? This is the Unix philosophy. If I build my tool small enough, the problem isn't in that tool. It's in the next one. So the only way I get away with building a tool that doesn't work is I've built 500 of them, and 498 have broken, right? But I still have 2 that never have been maintained because they didn't need it. And I would imagine there are similar, if you write 10 lines of Perl and that's your script, it can sit there for 15 years and never be touched. And that's actually one of the real beauties of Unix. And I hope everyone reflects on all that we've lost in the past couple months, because it's been a lot in our industry. So you can build operational software, right? And you have to think operationally when you do this. And I want you all to start turning the tables in the way, trying to bring the pendulum back to the middle, is that we don't want to put more dev in ops. We have a whole set of industry and companies that are really pushing on that hard, right? You will have to exert effort to stop that, all right? So it's going where it's going. It's not a bad thing. It's a very good thing to automate, deployments and all of that stuff. That's really good. Most of us have been doing that for 15 years. Now we're doing it a little bit more efficiently, a little bit more repeatably, and more importantly, a little in a way that's a little bit more easy to share. We're using the same language and syntax. But what we haven't been doing is putting more ops in dev. And one of the things that we've been very effective doing at OmniTI is when someone builds a piece of software, we have a philosophy that if it's not monitored, it's not in production. I don't care who it's serving or what it's running on. If it's not monitored, it's not production. So we'll get a call from a client and they're like, oh, this is down. And I'm like, I don't see it monitored. And they're like, well, how can it not be monitored? And I said, well, it's not in production because it's not monitored. It's chicken and egg, it's an escapist tactic. But the process of deploying something into production is to establish monitors that get buy-in from both the technical group to identify technical problems and the business groups to identify business critical problems together with remediation processes documented. When this breaks, it means this is the liability, this is who gets called, this is how important it is. All of that stuff has to be there. Otherwise, it doesn't count. So, hey, this is broken at 3 a.m., generally is responded to with, I think that's the most important thing to tackle tomorrow at 10 a.m. when we get to work. If there is a remediation process that says that's more important, the answer could have been, I need to wake up 5 people right now and they will not go to sleep until this problem is solved. But you can't tell me that at 3 a.m. You have to tell me that at 5 p.m., the earlier day when we put the monitors in place, right? So you have some controls over this. This is the processes that keep things sane. But the important thing is that when you build a piece of software that you have to be able to observe as operating correctly, you start to approach it differently, right? When someone says, oh, this is a queue, I'm putting things in the queue asynchronously. It's like, are you? And they're like, well, yeah, the code's right there. I'm like, I didn't ask if the code was supposed to do that. I asked if it actually worked. How many things did you attempt to put in the queue? How long did it take per item? What was the median time to get in the queue? How many are in the queue right now? How many does a queue think are in the queue if it's a broker, right? All of those questions, the last thing you want to do is ask yourself those questions for the first time debugging something in production. You ask yourselves during development so that you can instrument your system to answer all of those critical questions for debugging in production. When things don't work right, you go in and you say, I wonder how many are in the queue. Well, that's in my observation, that's in my instrumentation. That is there. So I think that, so dtrace, I'm a huge fan of dtrace, which is in Solaris and Illumos and Mac OS X and QNX and a whole bunch of other platforms, unfortunately not in Linux. Allows you to dynamically instrument basically any part of your system, from the kernel to user space to C to Java to Ruby to PHP. You can look at a running system and say, that sub static function there that's 7 lines long, that thing should always return 7. Is it not returning 7 right now? And you can ask the system, show me the return value every time that function is invoked, and it pops it out, and you're like, oh my God, it's 8. What the hell, right? And you can ask all these questions. Because that doesn't exist on every platform, I think really the onus is on you as software engineers to make sure that you expose enough of your application to answer these questions. The last thing you want to do is try to repeat a production problem in development to verify it's a problem, right? You can repeat it there to try to fix it and prove that you have a fix. But when something's going wrong in production, it's wrong, repeatable or not, right? So you need to be able to observe it there. So back to your organization. The CIO, the CTO is responsible for operations. I think in the future this will change because I don't think technology is a vertical anymore. Technology is in every company now. And there is a title for someone who's responsible for operations in a company. You can probably guess what it is. It's Chief Operations Officer. So a lot of times you look at COOs and they're considered to operate the company processes and human processes and HR and legal and things like that. But as technology becomes absolutely ubiquitous throughout every company in the world, I'd say 10 years from now, CIO, CTO will be only in research companies. It'll be like chief research officer. The COO will be responsible for operations, technical alongside everything else. But I don't think titles matter that much in this, especially in small companies. And this got a lot of laughs before. It's the chief operating officer, the chief information officer, chief technical officer, and chief make it fucking run officer. I think all of them are really appropriate. So the key is that someone has to make this stuff better. And they don't need a C in front of their name to do that, right? They need someone with operational acumen who has the ability and the access to change things in a better way. And that someone is you. Right, you have access to the software stack. You have access to the operations staff, to the operations stack. You can deploy things better, faster, stronger. And I don't think this mentality is just the beginning of of a career in web ops, right? If there's absolutely nothing wrong with being a web developer, right? You don't want to worry about the stack. I would say that if you are a web developer, you are not in a position to build the biggest and fastest sites in the world, all right? Just to be fair, there aren't more than 100 biggest and fastest sites. There are only 100 biggest, fastest sites, right? If one's tied for 99, then you don't even get 100, right? So there are a tremendous number of opportunities to build web applications where you can be just a web developer. And it's not a bad thing to be just a web developer or just an SA or just a database administrator. You can do all of these things and have an exceptional career. But if you want to be on the bleeding edge of scalability or performance, you really need to be a generalist. And I think that's what web operations is about. But all of this mentality is really for a career in anything, right? Go out there, be better, learn from your peers. I mean, it's about making yourself better and making sure you're in an environment that makes you better. And that's it. So, thank you.